now give a warm welcome to Lucas and let's talk about constraint programming.
So, welcome ladies and gentlemen. Thank you for joining me that late for such a hard topic. I even thought I have to do some algorithmics before I start because to warm myself up. No, I will start with a story because 1 year ago I was working for a company based in Berlin who was servicing high-end restaurants with their web application software that allowed customers to make online reservations in these restaurants. So the company came to me because they had a couple of problems and some of them were performance related. And you know, I would say some of these problems were homegrown and I leave that up to your imagination. But there was one particular problem that I bite myself into that I found is explicitly hard. So the problem was scheduling these customers onto the available time slots. So we had to determine the available days, arrival times, and tables a customer could book at one point in time on the reservation system. Not only doing that, we also had to adhere and satisfy a huge, vast amount of business rules. Like we had to take into account the available tables, the existing reservations, opening times, the size of the group, tests, business rules, release dates, what not, really, a lot of stuff. So I have to say, no wonder this code base really ended up in a huge mess. But as a programmer, I have to say I like hard problems. As I said, programmers like challenges. I'm definitely one of these persons. I really love challenges. So it came to me in one of these, I would say, late night problem Googling sessions. Google, thank you Google, revealed a paper to me with the title that literally says, Managing Restaurant Tables Using Constraint Programming. And at this point, I have to give a warm thank you to Alfio Vidotto, who is the author of this paper, who actually not only solved the business case for this company, but also really sparked my interest in constraint programming. And I want to, with this talk, spark your interest in constraint programming today, although it's really late. But maybe by the following example and the following introduction to constraint programming, I can inspire you, if you have such problem cases, to use constraint programming techniques. So I'm a fan of hands-on things, and I don't want to tour you through all the theory and stuff about constraint programming just nakedly. I want to give you an example and then break things apart. So there's a really nice sketch about XKCD that kind of goes like this. He's sitting in a restaurant, like restaurants seem to be a common theme and have really hard software problems in this area. So it goes like this. The waiter comes to the table and the guy at the table doesn't give up an order. He says, I would like to have appetizers worth in total of $15.05. And then you have I have the menu here with appetizers all costing different amounts of money. And then in the end, the waiter is like, what the fuck? What do I do? Because you would have to calculate all this. But let's help this waiter out and give him a program to solve this problem easily and swiftly. First of all, here we're dealing with a constraint. And a constraint is defined by a logical relation among several variables, each variable taking a value in a given domain. So when we take this example from XKCD into account, we have several variables. One being the total, here represented in cents. We have 1,505 cents. And the menu consisting out of 6 different items, all of different prices. Second, we could define our domain, which in this case is an amount per item on the order. This domain is way too large, of course, but in the end, it's about positive integers, positive numbers. It could go from 0 to infinity. In our case, it will not go that far, of course. And second, we clearly in this problem, we have a logical relation. So the total sum of the order we want to give up must equal the total amount the customer has given to us. So in the end, taking all these three things together and using constraint programming techniques, we can actually write a very declarative program that's just way easier done than said. You see it here, but I will show you directly. Here, I have the program. Mirror. Oops. I have the program here, and I will give it to you. Where's the magic of computers? It works. So, okay, coming back to the program that I've written for the waiter to solve this problem, we have the variables we talked about, the total and the menu. We have our intermediate order, and then I ask you, please speak loudly with me because Ruby is so expressive. Menu. Dot each. The amount per item. Is being chosen. From our domain, which ranges from 0 to 10. And is thus being assigned to our order, which we key by the price. Simply as that, because the prices are identical. Distinct. Doesn't matter. In the end, what we did here, we choose one value from our domain, assign it to our order, and then the next step is calculating the intermediate sum of our orders, which is basically we're summing up all the prices multiplied by the amount we have chosen. And then we just fail the execution if our current total, the total from the order, does not equal the total that we expect or the customer gave us. And if you execute that in the right window, it actually runs, and the customer will be served one mixed fruit, 2 hot wings, and 1 sample plate. You can check this out later, it works, and it's right. So, if you're asking yourself, what the just you're right, but you just saw an implementation of simple backtracking in Ruby. And not only that, but meet this guy, call with continuation. And to showcase you like how this works and how this fits together, I will do a little exercise for myself and remove the require, which I omitted in explaining what I did, and just re-implement the parts by using to back up this algorithm now with you. You don't have to speak out loud, but you can if you want to. So I start out here. This is the first thing that's not defined by Ruby. And we choose something from a domain. So let's choose from enumerable objects. Thank you. Joseph. Let's choose from the enumerator. And for each choice we've been given, first of all, we want to return a choice. But that's not sufficient, because if we fail, we need to return back to that point and pick the next choice. So that's where call with continuation comes into place. First of all, it's not here by standard, we have to continuation, we have to require it. And then we can do the following nice trick here. We can do a call CC block, which I will explain in a second, that wraps our return. And whenever we invoke call on the CB object here, the program is going to jump back to the place where call CC ended. So we need to make sure that we remember the callback. In this case, we call it simply backtrack, which is our backtrack memorization. We just put this into this array, which we will gonna initialize whenever we make a choice. That is not fully sufficient because, first of all, now we're able to, jump back to our point in time execution, like to our continuations with the call CC, but we also want to fail the execution when we're out of choices. So whenever the code reaches that part, the enumeration ended, we want to call failure, the same as we want to call failure whenever a constraint that we defined is not matching. So let's just define the failure method first. And it's quite simple because we just use backtrack. We pop off the last item from the array and we invoke call on it. So this works out nicely except for the case where we run out of options because backtrack is being initialized in an empty array. So one more thing we have to do, we have to do the initial item on the backtrack array is going to be a race to exhaust it. So that marks the point in execution where we have no more options, or we failed too many times and we have no more choices left. And if I'm good in live coding, then this should work right away. Yes. Well, so one mixed fruit, 2 hot wings, 1 sample plane. Right. So going back, you just met call CC, and you saw an implementation of simple backtracking in Ruby powered by continuations. But don't credit that to me. Please credit that to one of my biggest Ruby heroes, Jim Wyrick, who came up with this idea of using continuations for implementing simple backtracking. And I think it was at Ruby Quiz 70 or something, where the task was given to implement constraint solving algorithm. And he came up with this continuation idea so you can jump back in execution and return a new choice and then exhaust the backtracking pool by erasing this exception. Very simple idea, very powerful results. Simple backtracking, of course, in the world of constraint programming is just the mere tip of the iceberg. When we go back in history, this constraint programming topic, or the first research on constraint satisfaction problems, actually happened in the 70s. 2 artificial intelligence researchers started tackling these problems in 1974, Montanari, and Waltz 1975. The first systematic use of constraints in computer programming was described in a paper called Constraint Logic Programming by Jaffer and Lasse in 1987, which is, funnily enough, it's actually the year I was born in. And that's weird because in many ways, that's really inspiring as well to me, because when I tackle programming problems, it's weird because I always act with my current state of knowledge. But the problem is, so many years before, people tackled the same or similar kind of problems, and they actually did a lot of research onto them. So we all live in this programming world, and we have to deal with this huge, huge education problem. So that we have to, kind of search back way beyond the times we were born even to find solutions for problems we're tackling nowadays. That I find very inspiring, but also as a very positive and amazing argument for constraint programming because it's backed by 30 years of solid research. And if I just want to shortly blow you away with this table here, the constraint satisfaction landscape. So here you see the areas of research that have been done on optimizing these algorithms and optimizing them for different kinds of problems. I just showed you the tip of the iceberg is backtracking, and I just also introduced a small reducing of the search space. But then people have discovered numerous optimization methods, methodologies, and areas that you can use for your problems to make your programs run faster, to make your algorithms spit out more solutions to these hard problems. with the tip of the iceberg, I want to really encourage you to use constraint programming and use it for your scheduling and planning problems. So let's give it, you want to host a conference, and all the speakers have different arrival times, and it's really hard to figure out when to schedule what, and when you have a multi-track conference, it's even harder because you don't want to, put the JavaScript people next to the pun left open, I don't know. So you have constraints when you schedule and plan things, and you have a limited amount of resources. You want to pack as much into your conference as possible. Basically, classic problem for constraint programming has been solved many times. Same as the restaurant, we're using the same techniques there, and we could schedule and plan more efficiently. Same goes for resource allocation problems. Whenever you have a constrained space and you want to optimize the resources you put into that space, constraints programming really help you a big deal with that. I'm actually working for a number of Kubernetes clusters right now, and one of the tasks I'm doing there is I'm writing a scheduler, an autoscaler, like an intelligent rescheduler, that is basically taking your containers and putting them into the service in an efficient manner, so that the server's resources are being used more efficiently. Classical constraint programming problem that you can use to solve it very efficiently. So for me, these are not only problem areas I would definitely use constraint programming, but a second thing I really like about constraint programming is the modeling way. So when I program, I love when I can think about my programs like very straightforward and in a way that feels natural to me. And especially with constraint programming, one of the traits that declarative programming in this case brings with it is that you can model the programs very closely to real world entities. So whenever I think about the problem, it's almost the same thing I read when I write my program. So I have my variables, I have my constraints, and it executes almost sequentially, and this is the same way my brain works. Then second, I really like working on areas where there has been some research put into it. So in this case, like a vast amount of open research has been put into optimizing really difficult problem areas. And then third of all, putting these things together, I think if you have a clear mind about your problem and you have a good understanding about your problem, it's really good to tackle these really NP-hard problems. Just as a short recap, NP-hard means problems that are very easy to evaluate. In the end of the restaurant example with the XKCD sketch, it's clear. You can just sum up the order the waiter is giving you, and if it's not 1505, it's wrong. Easy to evaluate. But it's really hard to find a good solution to present to the customer. So these are the problem space of NP-hard problems. So it's always about optimizing a given amount of resources and finding the optimal solution. And these problems are continuously being tackled by researchers. And I wouldn't say constraint programming is the ultimate weapon against it, but clear modeling and a clear mind can give you a huge deal more of opportunity and chances to succeed in these areas. With the restaurant case that I've been working on a year ago, we had way more variables than in the XKCD sketch, for example. We had way more constraints. For example, we would have to implement a constraint that would say, at the beginning of the restaurant opening, we should seat the people like distributed across the restaurant so it looks fuller, right? So in the end, all of these things, you would say as a normal programmer, like, I can't do it, it's too much, it's too complex, simplify it, right? But in the end, if you allow it, and if you write a programming in this way where you can say, I can tackle these constraints one at a time, whenever they are present and whenever they're being asked by the program, you can actually model it in a nice way that they're still being solved efficiently. So I hope I could spark you a little bit, and if you're interested in more, I will publish these slides later on, and there you will find a good amount of resources to get you started with constraint programming, and also, of course, the example cases. There's numerous toy examples that I can show you later on if you want to. You can come to me and I can show you some really nice toy problems. So if anybody heard about the N Queens problem, maybe? So you have been trying to get hired by TopTal, maybe? Right, so if you want to get hired by one of these, you should tackle these problems, all NP hard problems, and maybe constraint programming will help you a great deal. N Queens is a problem where you want to say, you want to put an N number of queens, the chess figure, on an N by N chess squared board. And in a way that they don't attack each other. Really interesting problem because queens have a really wide attack range and they don't leave much space for other queens to be placed on the board. Still, you can solve this problem in a, let's say, decently efficient manner with constraint programming. I've written one. I will publish it later and give you the information on that as well. Also, I want to make you aware about some upcoming events in the constraint programming sphere. Especially in this summer, there's these constraint programming summer schools. I'm trying to attend one of them this year, and also there's a conference series you can attend to get the latest research on constraint programming. And with that, I think, thank you, and I will leave you to this.
So thank you very much, Lucas. Do we have questions from the audience?
Fire away.
Have you also worked with genetic algorithms?
Not so much. No.
Because I was working on an app where I had to solve pickup and delivery problems for messages, which is also NP-hard. And then I found out about the Google operation research tools.
Yeah.
And they offer a great library for also solving constraint problems.
Definitely, yeah, definitely. Yeah, I mean,
it's not available in Ruby, but
there's not only a lot of research that's being done into these areas, there's not only theoretical research happening, actual practical implementations are existing. Like what you mentioned, the Google OR tools are an insanely great tool set for tackling all kinds of these problems. I don't think there's a direct Ruby binding available, but you can use them in JRuby because they have a very good Java library available. Other than that, I think the Ruby world hasn't seen much of libraries that are being brought up into life in this sphere. Yeah. But the OR tools are really nice. Yeah.
Yeah, I personally, like I found it really hard. Like when you read these papers, sometimes the algorithms are so hard that you can't even implement them.
Yeah,
by just reading the paper. So Google does a great job for like showing you how to implement these algorithms.
They do a really good job. And I actually have this problem too because I'm not an academically trained programmer. So I'm self-taught and I have really hard time reading the mathematical definitions from papers. So I thought about, that would be really great if somebody knows about reading these mathematical formulas and how to put them into code. Come talk to me because I'm really eager to put a lot of these formulas into code, but I have a really hard time reading them and understanding them. So we should come together. Right. Here.
Is constraint programming similar to or the same as logic programming, like Prolog?
So Prolog has constraint programming built in. And I don't know specifically about the definition of logic programming in Prolog. I never did Prolog.
Yeah, like that. I'm familiar with something called logic programming machines, very similar. Like there's like N-Queens is a common
and maybe it's how they name it in the Prolog world. But for example, Prolog definitely has native support for constraint programming. Yeah. Oh, and it sounds very similar too.
It's probably the same thing.
Yeah. So whenever you have variables, domains attached to these variables, and logical constraints, we are speaking about constraint satisfaction problems. Yeah.
Okay, one other question? Maybe 1, 2, 3, no? Okay, then thank you very much, Lucas. talks, Devin or Bodo, whoever is up first. No, Bodo's up first. Devin can already get ready. Can do that, and while we have the little Umbau pause as usual,